The aim of this experiment is to study the properties of acids and bases. So for acids, we'll be using HCl, and for base, we'll be using NaOH by the reaction with litmus solutions, blue and red, zinc metal, and solid sodium carbonate. The material required to perform this experiment is some test tubes, a test tube stand, test tube holder, burner, dropper, delivery tube, matchbox, blue litmus solution, red litmus solution. You can also use litmus paper strips instead, zinc granules, dilute hydrochloric acid, a solution of sodium hydroxide, powdered sodium carbonate, and freshly prepared lime water. For the first part, we will test HCl and NaOH with litmus solution and see the changes observed. The changes observed would be that when we add blue litmus to a dilute solution of HCl, the solution turns red, indicating its acidic nature. Likewise, when we use red litmus with NaOH, we will find that the solution turns blue, indicating its basic nature. So let us perform this experiment now. We'll be using pH paper strips or litmus strips to identify the acidic and basic nature of HCl and NaOH respectively. Let us test HCl and NaOH with the help of litmus paper strips. So I have red litmus and blue litmus paper strips with me. When we dip a strip of blue litmus paper in HCl, so I have taken HCl in this test tube, you can see the change in color. You can see the strip turning red. You can compare the colors here. It was originally blue and now it has turned red, showing that HCl is acidic in nature. You can compare the colors here. Look at this. And then if we dip a strip of red litmus paper in a solution of sodium hydroxide, you can see that it's turning blue, indicating the basic nature of sodium hydroxide. With sodium hydroxide, you can see the change in color of red litmus paper, it turned blue. And with HCl, you can see the change in color of blue litmus paper, it turned red. In the second part of this experiment, we are going to test HCl with zinc metal and similarly NaOH with zinc metal. So for the first part, when we add HCl to some zinc granules that we have taken in a test tube, we'll find that a gas is evolved, and if we test that gas with a burning splinter, it explodes with a pop sound, indicating that the gas evolved is hydrogen. Similarly, when we add dilute solution of NaOH to zinc granules, again gas is evolved, and when the gas is tested with a burning splinter or a burning candle, the bubble explodes with a pop sound, indicating that the gas being evolved is hydrogen. So the reaction occurring here is zinc reacts with NaOH, resulting in the formation of sodium zincate and hydrogen gas. Let us now check the behavior of acids and bases with zinc metal. So I am adding piece of zinc metal to acid, that's HCl that I took in the test tube. So if you look at it closely, you will see some bubbles being formed. These are bubbles of hydrogen gas which are evolved when metals react with dilute acids. And if I add a piece of zinc to sodium hydroxide solution, you can again see the formation of bubbles, indicating that bases also produce hydrogen gas when they react with metals. You can see the bubbles being formed and escaping out of the test tube. You can see some bubbles sticking on the surface of zinc metal as well. So the small little bubbles are there, but the larger ones are also being emitted. So as the reaction proceeds, the number of bubbles formed will also increase. The third part of this experiment, We are going to test HCl with sodium carbonate and NaOH with sodium carbonate. So when we add sodium carbonate powder to a dilute solution of HCl, we can see that a brisk effervescence occurs, and if we pass the gas through lime water, it turns milky, indicating that the gas being given off is carbon dioxide. Whereas when we do the same thing using NaOH, that means when we add sodium carbonate to a dilute solution of NaOH, nothing happens, indicating that NaOH does not react with sodium carbonate.
Now add solid sodium carbonate, that is anhydrous sodium carbonate, to HCl. Look at the effervescence. So with carbonates, metals, they produce carbon dioxide gas, so the gas that was evolved is carbon dioxide. And we'll also do the same with NaOH.
So you can see no reaction occurred here, indicating that sodium hydroxide does not react with sodium carbonate. Now the observations that we have seen performing the three experiments are that when we tested HCl with litmus solution, blue litmus turned red, indicating the acidic nature of HCl. When HCl was tested with red litmus, no change occurred, indicating that it does not cause any effect on red litmus because it's already acidic in nature. When HCl was tested with zinc metal, a colorless gas was evolved. We could see the formation of bubbles. And when we tested that gas, it was hydrogen because it bursted with a pop sound. And when HCl was tested with sodium carbonate, again a colorless gas was evolved with a brisk effervescence. The gas evolved was carbon dioxide because it turned lime water milky. Then for dilute NaOH, the three experiments that we performed, with litmus solution we observed that it turned red litmus to blue, indicating its basic nature. It showed no change with blue litmus because of its basic nature. When it was tested with zinc metal, colorless and odorless bubbles were produced, which indicated the presence of hydrogen gas, which we confirmed by burning that gas or by bringing a burning splinter near the gas, and we found that the bubbles exploded with a pop sound. And with sodium carbonate, NaOH did not show any reaction. So we can say that sodium hydroxide does not react with sodium carbonate.